Okay, so let me go over our first problem of the class. So we have this fellow. Then we have
Wait, did you get permission?
Yeah, I got. He is going to just give you.
Accept me, yeah?
Can you please mute the mic, by the way? Okay. Okay. So we have this fellow, then we have this fellow, then we have this fellow. Okay. The problem says that this is more like a cantilever. Do we have anyone who is not with laptop right now? Everyone is with someone, right? Huh? Yes? What?
The meeting host will let you in soon. Please allow her to.
Oh, okay. This one is ninety feet-pound of torque. We have, can you please mute the mic? Okay, this one is A, this one is our B, this one is C, okay, the question says that if this dimension is 5 inches and this dimension is 5 inches, you have to find, what do you have to find? Okay, you have to find TA equal to question mark, TB equal to question mark. So first thing first, is this a statically indeterminate problem? The answer is yes, right? Because if I just ask you, my voice is 100% clear, right? To our online students. Hassan, right?
Yes, Sujam, it's clear.
Okay, so this is a statically indeterminate problem. How would you proceed? So in the solution, the first comment that you have to make is, because you cannot find the torque at A and B, right? You just cannot. The one way out is if you say that since it is a cantilever kind of a formation where this fellow is inside this fellow and this is inside this fellow, so our phi total will be, any comments? Phi total will be 0 degree, right? Yes, no? So I will say that phi total equal to phi AB, phi AC plus phi CB, correct?
So why it is zero?
Yeah, because this is inside this and this fellow is inside this. So when you are putting a torque, the total twist will be Zero. There will be no change of angle. No. If I have firmly put some structure like this, and I'm putting a torque, what will be the total twist end to end? What will be the total change in angle end to end? Nothing, because I'm holding it. You see here, I have held it, right? This thing goes inside the wall, and the right side also goes inside the wall. Now from the center, if you are twisting, the total phi will be 0. So what is phi AC? Phi AC will be, okay, what was the formula? Why don't you tell me? TL over GJ, right? And again, this will be our AC, correct? This will be AC, 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 correct? And what will be my phi CB? It will be phi CB will be T CB L CB over G CB J CB, correct? Okay. So all you have to do is, hang on. Are you understanding the question? The question is, what is the torque at the support, the reactions? What I am trying to tell you is that you cannot solve this question, because if there is a torque acting in this direction, then all of you will tell me that TA plus TB is equal to TA plus TB plus 90 equal to, let's say, 0. So you cannot find the torques at the supports. Are you getting my point? There is just one equation. So this is why it is called a statically indeterminate structure, because your statics classes are raising their hands and they are telling us you need to start the 206 concepts for us to crack the TA and TB, the reaction torques at the supports. Are you getting my point? So that's why just by looking at TA plus TB, we were raising our hands, and then we started the 206 concepts. Now the additional equation will be given to me by this. So now I will say that let's say this is my free body diagram. There will be another, right? And now I will say that I am assuming both of my reactions have anti-clockwise here, and this is my 90 feet pound. This is my TA anti-clockwise that I am assuming. This is TB, correct? Now I am saying that I need one more equation, which is this one. I will use that in conjunction with this one. Two equations, two unknowns will give me TA and TB. So I think now you understand the reason why are we doing this. So phi total is 0. So we are, I think, back in business. Now all we have to do is write.
So we won't be needing the diameter of the rod?
Yes. No.
For
No.
J,
Huh?
for J, for finding out J.
We will see. We will see. So now we will proceed and we will say it will cancel out is the answer to your question. Yeah. So I will have phi AC will be T AC L AC TL over GJ, was one of the students who told me. Okay, plus the next one is phi BC, which is T BC L BC over G J CB equal to 0. So the diameters are the same. A solid shaft, and the diameter of the portion AC and BC, the dia is the same. So this fellow will cancel. The this fellow is made of the same material. This will cancel. And I will be left with nice and beautiful TAC. Hang on. So why don't you help me in this part? So do it and tell me what are you getting?
30 times 5 inches across.
Oh,
30
in fact, hang on. I'm so sorry. The dia is not the same. Let's say they are of unknown. So I think the student was right. So let us keep this as it is. Let us cancel the LAC, and I think he was right that it should be specified. We even don't know whether they are equal in dia. But LAC and LCB are given to me. So now I will get 654321. Okay, material is the same. At least this is given to me. Material throughout is same. So at least I can cancel this one. So I will have TAC over GAC. Oh, I will go back. Give me 1 second, please. TAC over JAC. I'm going back. Is equal to minus TCB over JCB. Minus TCB over JCB. Done? Okay. Okay, I will call this as my equation 2 and this is as my equation 1. Yes.
For the part, we set that phi total equals 0 radian.
Huh?
So this rod is stuck on wall, and another part is also stuck on the wall.
Both sides are penetrated into the wall, so it's holding them very rigidly.
Very rigidly, okay.
Very, very tightly. So it's inside the wall. It's more like a cantilever. There is no way that there can be an angle, because this rod is inside the wall. The other side is also inside the wall. Let's say they are held very rigidly.
But we try to twist at the middle part. So the angle change, like,
Yeah, there will be. But the point is the phi total will come out to be 0. That's what I'm trying to tell you. Phi total is 0.
one of them is negative and one of them will be positive, and
Yeah.
they will be same. Okay. I get it.
Yes. In fact, he's right. Look, this chunk and this chunk, their addition is 0. You're right. You are absolutely right that there will be twisting, but the total fellow is 0. Okay, done. So now all you have to do is 2 equations, but you need to have TAC and TCB. So how can you get TAC? Well, you need to understand that this is TAC and this is TCB, whereas you have TA and TB. The supporting torque is the torque at the support, the reaction is TA, and the reaction on the right side is TB. What about TAC and TCB? So
TAC should be TAC, let's say, or TAB के लिए if you put a cut and we take
Good.
it as 90 minus that.
are you getting? He's saying make a cut. Okay, good. So I think everyone is with me. You make a cut. So we make a cut, and then we look from, let's say, that side. When I'm looking from that side, I will say T AC, right? Why are we looking from that side, by the way? Okay, hang on. TAC plus, no need to see from that side. I think when we are cutting it, after cutting, I will throw this chunk away. I think we will be looking from this side, no? So I will say TAC plus TA, because TA, if you remember, is nice and beautiful anti-clockwise. So TAC plus TA equal to 0, and TAC comes out to be negative TA. Okay, then I will say again make a cut, throw this chunk away and see from here, nice and beautiful. This time I will say T, oh come on, TCB, then plus TA. But now I also have, I think 90 as well, right? 90 feet pound feet equal to 0. So now I'm writing TCB plus TA plus 90 equal to 0. Boom, 2 equations. So I will say this is my equation. Let's call it as 2A. And this equation, beautiful, is 2B. Now I know that all of you are getting confused. Where are we heading with this? Well, all I have to do is now inside this TAC, write minus TA, and inside this TCB, write this.
Yeah.
Huh.
For TCB, isn't should be in negative sign in is coefficient, because TCB will be negative side, and therefore there will be 0.
Oh, you mean the TCB I should consider clockwise? Okay.
Yes, yes, sir.
Both of you are right then. But I don't know, actually. I'm not even thinking that much. I'm just going with the maths. I'm going with the maths. I just assumed anti-clockwise and I'm letting do the maths take decisions for me. You will have to join one of the students because the connector is not working. So yes, thank you. Okay. So you are right. You are right. In fact, when we see the answers, you will be right. But I am just coming up with probably wrong intuitions right now. That's fine. So 6, 5, 4, 3, 2, 1. So I will say TAC comes out to be negative TA and TCB comes out to be negative TA minus 90. Okay, I call this as my 2A and this as my 2B. I will go back, substitute in equation 2A. Sorry, equation 2, right? So sorry.
We did a mistake with the sign, because when you are going to equate it, T and T are going to cancel out.
Which one will cancel?
Come to the next slide that we were on.
Okay.
When you are going to equate 2A with 2B.
When I will equate
2A with 2B.
Oh.
Minus T and
No, why would I equate 2A with 2B? No, I will not equate the equation 2A with 2B. You thought that I would equate equation 2A with 2B? No. Hang on. No. So
his going to add them and make equals to 0.
No. Then I will tell you what I'm doing. Look, this is the reaction torque TA. Here I have reaction torque TB, right? When I am trying to find them, I said TA plus TB plus 90 equal to 0. I needed one more equation. For that, I said the total angle of twist between the ends total will be equal to 0. For that, I'm using the formula phi is equal to TL over GJ. In those formulas, I have those TAC and TCB. Are you getting my point? Now I am finding the TAC and TCB in terms of the reaction torques, which I wanted to find. Are you getting my point? Now I have got TAC and TCB. Now I will substitute in 2. Got it? Okay. So I will substitute in 2. So I will have, you do it. Please try to do it. We don't have projector. So it just makes, I will, yeah, ironic. Last week, actually, I lost my bag. In my bag, I had an extra connector. And today the connector broke as well. Anyways,
John,
ah,
what you said, G are not the same.
huh?
You said G's are not.
Yeah, G are not the same. Did I cut? No, G's are same.
Same, huh?
G's are same. J's are not
J.
same. So material is the same. The length is the same. Material is the same. So G cancelled. Length is same. So length cancelled. So I will write TAC over JAC. No, okay. What is the question? I will come to your desk. TAC over JAC plus TCB over JCB equal to 0. Okay, there was a question. Any questions?
Yes, what about JAC and JC?
We will write the answer in the form of J's.
Okay.
Or I can give you a diagram.
Yes, you can give us-
I can give you the diagram. It's not a problem. So now TAC is equal to negative TA over JAC plus TCB is minus TA minus 90 over JCB equal to 0. So now all you have to do is now I understand the problem. 5 inches is not that length. 5 inches is the dia. So 5 inches is like 5 inches is like this much. Like how it can be the length, right? So the answer to your questions is answered that 5 inches is the dia. No, but if then hang on, then anyways, I will look into my notes probably and figure out. Okay, let us proceed. But anyways, okay. Yes, I think this length is 5 inches. Okay, I just realized that in my notes it is written that JAC. Thank you. Yes, I know. JAC is 57.6 into 10 power minus 3 inch power 4, and JCB is 42.6 into 10 power minus 3 inch power 4.
So these are given or?
Given. No, given. Of course, they are given. So now all you have to do is find it. So I will get TA is equal to TA. We will have, let's say, minus TA over JAC minus TA over JCB, and then I have minus 90 over JCB equal to 0. So finally I get TA into okay, I don't know. Did I make a mistake?
But we can put plus sign
Yeah.
as a coefficient because we can cancel the negative part and we can.
Oh yeah, we can. I'm just figuring out in my notes. JAC. Okay, yeah, you are right. So I will cancel the. So we will have TA into 1 over JAC plus 1 over JCB equal to 90 over JCB. And finally, I get TA into 1 plus JCB over JAC equal to 90. So you give me the answer of TA now.
Coming is 51.
51 point? Negative or positive? So I was wrong. Are you with us? Sure. Okay. TA comes out to be negative 51.7 feet pound.
And the other one is 38.3.
Okay, negative or positive?
Negative.
So my intuitions were wrong and you were right. TB is minus 38.3 feet pound or pound feet. So this means this is clockwise and this is clockwise. You're stopping here for 3 minutes just ask the questions. Yes.
So they will be in opposite direction.
Oh, for sure.
without assumption.
Of course, but if I am putting an anti-clockwise torque, the reactions have to be clockwise. But I just assumed anti-clockwise, which was wrong.
So in this case, anti-clockwise is positive. You assume.
I assume anti-clockwise is positive. Okay, what about our online students? Everything is fine? Everyone is online today, by the way.
In our solutions, we need to say that anti-clockwise is positive and clockwise is negative
Yeah.
in our solutions, right?
Yeah, you should mention this. Okay, and just as a quick comment, you can take this as your exercise. You could have actually cut this section, let's say from here as well, and started looking from this side. Again, this will become a more statics kind of a activity, but you can do it yourself. So you can see the same results. Should I skip this part where you cut and start looking the other way? Sure, all of you can do it. Okay. So let us. Okay, let me ask our online students. Abdullah, Ehsan, Charu, Mehmet, Safatash, Melissa, Revis, Uze. Any questions? No? Okay, so let us go to our next problem, I guess. We have, let's very quickly do another problem. So this time around, the problem says we have, okay, this one you are doing it yourself. The problem is something like this. We have and this one is, then I have, okay, and have then we have this one. Okay, it says that I have, okay, now I have a hole in this fellow. Right? And the question says that if you have 250 Newton meter acting clockwise and 2000 excuse me, 2000 Newton meter acting clockwise, the question says, okay, let us see the values that I need to give you. because otherwise that confusion starts. What are the values? The first one is 0.6 meter from here to here. 0.6 meter. Hang on. So yeah, that was indeed 5 inches, by the way. In the last problem, the dimension 0.6 meter. Okay, this dimension is 0.2 meter. This definitely doesn't look like a 0.2. I think I made the problem not per scale. Okay. Now the question says that if this fellow is 0.4 meter, the dimension, and the dia is 30 millimeter, and this dia is 44 millimeter, inner dia is, because this is a hole, right? So 44 millimeter is inner dia, and the outer dia is, oh come on, what is the outer dia? Outer dia, 60 millimeter is the outer dia. 60 millimeter is the outer dia. Okay. Okay. So sorry. Yeah, it's a hollow from. No, this is solid. And then this is solid. And this is like there is a hole that is drilled from here to here till this depth. Okay, the question says you have to find the total, find the A, this is your A, this is B, this is C, and this is D. Find phi A. Okay, I'm not doing it, you're doing it. Tell me, how would you start? So do it. Do it. Okay, can our online students respond? Everything is fine?
Yes, Ajam.
Okay. Today our projector is not connected.
For the first voltage, that is B.
No, if you cut from here and and you throw this chunk away, your torsion is going to torque. Supporting torque, there is a reaction torque. There is a reaction. There is a reaction, of course. No? Yes. Yes.
Also, do we need G for this example? We don't know G. The G divided by G times J.
If it's the same material, then TAB, LAB over G, LAB, G.
And all of these will be lost.
If the same material, then G will go on the right hand side and it will cancel, vanish. Of course. If I'm the one who is forgetting to mention. In an exam, hopefully I won't. So same material. For example, one of the students asked that why didn't you give us the G? So material is the same for the whole. It's the same shaft actually. So of course for the shaft, of course. It's not two different materials that are welded together. It's the same thing. So I will write first equation is phi A, the only equation I'm sorry, phi A equal to phi AB plus phi BC plus phi CD. Okay, that's it. Now all you have to do is finish this. So phi AB is equal to TAB. What was the formula? TL over GJ plus TBC over G. Good. GJBC plus we have TCD LCD over CD. So this is our phi A. And now you can finish the question quickly by saying that keep making the cuts. You make a cut. So where would be your first cut? Of course, it is a hole that starts from the support, goes all the way up to 0.6 meter. So make a cut through the hole, right? Are you following me, everyone? Okay, so it will become T CD or DC, whatever. Okay, I throw the whole chunk away. Oh, come on. I throw the whole chunk away. And I'm looking from this side, right?
So can we start from the other side?
You can. Yes, 100%. So I will TCD plus. So let's say my support has a nice and beautiful this fellow, right? Support. There is a support, has reaction torque. Let's call it as TD. In fact, I think we can follow his strategy starting from right. No, I don't know.
Starting from right, I think easier with that.
Okay, anyways, okay. Anyways, now I have started, so let me finish. TCD is anti-clockwise and 250, 2000. So I will have TD minus 250 minus 2000 equal to 0. So the support has 2250 Newton meter of. So now I will say that TD is actually anti-clockwise. So I will say TCD, let's say after cutting, I am assuming anti-clockwise plus TD. So for students who are getting confused, I cut this, throw this chunk away, and I'm looking from this side. So plus TD equal to 0. And TCD comes out to be my answers are coming out to be different. I don't know. That's not good. Anyways, so TCD comes out to be negative TD. And TCD comes out to be 2250 Newton meter. So this means the TCD right now for me is coming clockwise. You can compare with the way you did it. No, that's not good. My notes say otherwise, by the way. So if this whole thing is clockwise, the reaction will be anti-clockwise. So TD is anti-clockwise. So when I cut this chunk and throw this away, then the face will be, yeah, this is correct. Now I will proceed and similarly, let's talk about what is the second? TCB. So again, I will cut from here and I will throw this chunk away, right? So I will say TCB. Okay, anyone who can tell us what is TCB? Anyone who did TCB, by the way? TCB is no, the same thing, because you cut from here, you throw this away, again you will get the same thing. Yeah, so TCB plus who said TD? Good, equal to, thank you, very good. TCB equal to again negative 2250, again clockwise. And then you will proceed with the BA. So your TBA will be TBA. That will be anti-clockwise at reaction. That is a TD, which is 2250. But now you also have 2000 in clockwise. Yes, no? So equal to 0. And TBA comes out to be 250. So I have TBA coming out to be plus 250 Newton meter equal to 0. And TBA comes out to be negative 250 Newton meter. Okay.
It's also in clockwise direction, right?
I have to check, double check. Yeah, clockwise. Good. So now I will start picking all the chunks together. This is 1, 2, 2, and anything else?
And TCB.
TCB, where is TCB? Here. Boom. Done. Okay. Okay, so I will now 6, 5, 4, 3, 2, 1. You do the rest. Show me. Done. Do the number. Yes. I will take that. Oh, I think we still need G. We are not equating them to zero anything. Sorry, I think you need G. He's right. G is, yes, sorry. The G is given, by the way. Thank you. It was a very good comment that we need G. So that is 77 into 10 power 9 pascals. Thank you. He was right. This is not one of those statically indeterminate problems where you have summation equivalent. Yes. Question? No question?
I'm trying to find the.
Okay. I'm not going anywhere till you give me the answer. So our online student can chat message me with the answer.
Imprisoning us.
Sorry?
So you're imprisoning us here
Yes.
until we solve this.
Oh yeah. We are not going anywhere means.
So can we leave after we get done?
Oh yeah, of course. In terms of progress in the session.
Most popular is TBA. And in this part, we should TBA. So, can you post it for me?
TBA, TAB doesn't make a difference.
And they are saying.
No, yeah. Here, TAB, TBA, it's just name for me. The section AB of the.
Okay.
It's not like dynamics, like. Okay. Anyone who can please give me the answer now?
For example, you can come forward here.
Yes.
They correct on
No, I just told you.
No, these are the torque values. You have to find the J yourself. So I can give you the formula.
J is related to
I will tell you. So this is J is equal to pi by 2 C power 4, right? And this is for hollow. For hollow. I don't have the answer. I will give, just give me 10 seconds. We will see your answer. G hollow is, can you give me the formula? Pi by 2?
Pi by 2 radius power 4 minus inner radius power.
So, were we calling C2 or C1? Like this? Okay. For hollow shaft.
Could you confuse for
Go back?
Yeah.
Okay. Yeah, of course, I think I made a mistake by saying material will cancel. How can it cancel? We are finding the phi A. Okay. Okay, you can give me the value of JCD, by the way. JCD. 9.04.
And do we have to convert millimeter into meter?
Yes, of course. So JCD comes out to be pi by 2 C1 power 4 minus C2 power 4, which is equal to pi by 2 into 30 power 4 minus 22 power 4, which is equal to 9.04.
Then given in millimeters, so aren't you taking millimeter to meter?
Yeah, I have to convert it.
Yeah.
So I will do a 1 by 1000 power 4, okay?
Yeah.
Okay, and what about JAB? It is equal to pi by 2 into 30 by 1000 power 4, which is equal to 7.95. 10 power minus 8 meter power 4.
Oh, okay.
So this was our problem from the side view. There was, this is our fellow, and it was here, support, and then we have hang on, sorry, we have a hole till here. This is 0.6 meter. This is 0.2 meter. And this is 0.4 meter.
First, isn't that supposed to be 15?
Sorry?
13 is going to
Yeah, so dia is 44 millimeter. And inner dia. And this one is 30 millimeter. Oh, your question is?
Because the diameter is preferred for isn't it supposed to CAB and supposed to be 15 millimeters?
Oh, okay, I will look into it. Okay, you are right, I think. This one is 60 millimeter, our outer dia, and this is 30 millimeter dia. Okay, so his question is, yes, so it is 60 divided by 2 minus 44 divided by 2. Yeah, this is correct. And for solid shaft, okay, I think he's right. So,
It has to be 15.
oh,
Because you took the half.
yeah, okay, I think he's right. Can you please do this by calculator? What is the answer you're getting? Do you get 7.95?
Sir, for the pink box,
For the pink box, do you get 7.95?
1.27.
Okay, so this means it's wrong. So he's right. Thank you. 15, okay? Now you can do 15. Do you get 7.95?
Yeah, it
Yes.
Okay, thank you. So finally, our phi AB comes out to be phi A equal to summation of all these chunks. Whatever the answer is in radians. Okay. Do we have any questions from anyone? Abdullah, Ehsan, Charo, Mehmet, Safat, Reeves, Uzair, Ebu. Yes?
What was the answer?
I don't know actually.
Just if you have to take one.
So what are the answers you're getting? Anyone? Did you do it? No? No, 0.06 is in radians, right? So you convert, multiply with 180 by pi, you will get in degrees. So multiply this. So seems reasonable, yeah. But again, I don't have the answer. Okay. Now, just one quick remark that I want to make. That is that when you are substituting here instead of TAB, hang on, everyone, just quick remark. When you are substituting values, you will not put TAB is equal to, let's say, minus 250. Here you will put 250, not minus. It will be opposite, right? Because this is applied torque.
So you don't put the right sign.
No, we do the opposite because those are the reaction torques. In this formula, these are the applied ones. If that had been positive, this would be different direction. This one is TBC is 2250 and TCD is again 2250. Okay, I have to proceed now.
What's the final answer?
What are you getting?
In radian, it's 0.0403.
Okay, 0 point.
That's in degree. That is in degree.
You can double check.
You found the value of what?
Yes.
What did you found? It's like 2.31 degrees.
Seems reasonable, but I don't have the answer. You just use the calculator and double check. Okay, everyone, let's and the lens are given. Okay, we have question. Okay. Really? I was actually trying to save time because we lost 10 minutes at the beginning. Okay. Okay, so we have
Sir, dynamics equation further is a problem.
What is the problem in dynamics?
Sir, वो science का थोड़ा सा मुझे confusion है. Just like if I'm taking PCA with respect to X, Y, Z, उन चीजों में मुझे थोड़ा confusion है.
Okay, so office hours. When are you free today?
Today after 3:30, I have back-to-back classes till 3:30, and then
I have a meeting from 2:40 to 3:40. So I'm free at 3:40, I think.
already our process.
TZ 29 3:40. Let me double check.
O C'leri ayrı hesapla. Sonra direkt bulduğun C'yi yaz.
Today is Wednesday, right?
Equation.
So
Mesela üstü
yes, Wednesday I have only one meeting till 2:30. Okay, I am free from 2:30 and you are free at
3:30.
okay. So let's meet at
3:40.
3:40.
TC 29.
3:40 at TZ 29. Okay. Okay. 3:40 TZ 29. Okay.
C'leri ayrı hesapla yaz. Sonra equation. En iyi söylemedi. Ben istediğimi aldım.
Anladım.
So we have 10 minutes, right?
5 actually.
5.
5. But it's fine. We will start at 11:52 in my laptop. So we have 3 minutes left. Today's day was complicated because of the connector. Aluminium, and we have aluminium and this one is 8 millimeter, right? And this one is 500 millimeter. So you did have a look at the midterm exam one date, right?
Yes, I think it's on the 24.
Okay, you have to double check. I don't remember. Okay, so this is 76 millimeter. Correct.
So in the exam, you're going to ask us about the questions that we did in class, right? Like similar things.
Well, I can ask you something different as well. As long as you're clear in your concepts, you should be able to crack the problem. Okay. Now, okay, this is now let me show you. This one is 50 millimeter.
Such a nice material.
Yeah. So technically you have aluminum. It's like a hollow, and inside it you have a steel. So probably I need to remove this because it is creating confusion. And now I think the drawing should be clear. I should make because this is hollow. Is like this, right? I think that's clear. So if you look at the side view, you get something like this. And this is now this is our orange line, and this is done. Okay, here is our nice and beautiful cap. You have a torque. Okay, now I will put the green lines. Yes, no? Okay. And here comes the okay. The question says that you have shear stress of steel allowed equal to 120 megapascals and shear stress aluminium. Okay. Let me use the same color. Shear stress of aluminium. Again, it is allowed equal to 70 megapascals. That means should not exceed. Should not exceed. Should not exceed. The value of G is 77 gigapascals, and for aluminum it is 27 gigapascals. Find the maximum T naught. So just so that everyone understands what the question is, I will first make a drawing. So let's say if you have this as your layer, let me use purple here. Okay, Abdullah Amir has joined the session. Hello, Abdullah, how are you? Oh, you are Abdullah Amir.
Sorry.
Okay, that's I I remember you from okay. Okay, yeah, here it is. So let me make it's the 7th time I'm attempting. Anyways, I think you get my point that this is a little thickness I'm creating. Done. So this is our T node in this direction. Oh, come on, don't tell me it is gone again. Okay, I'm not making it again. T node and whatever it is. Okay, now we have two chunks that are, if you can please reduce the volume. This is T aluminum and the other chunk is T steel. Both of them are resisting. So the question says find T naught. Okay. The whole point is that you have a hollow aluminum, thin, very thin. We can consider a Coke can, right? Very thin aluminum. Inside it, right at the center, you have this steel rod, right? Did I make a steel rod at the center? Now, right at the tip of it, you have this cap, right? So you put this cap right at the tip. Then on that cap, you are applying the twisting motion. You are putting a torque, a torsion. The question says that you have to find the maximum torque that you can apply to this structure. Now, why did I make this cap? This one. Why? I made this cap because I want you to remember that we are putting the torque on both the fellows. Hadn't I put this torque, you would have got confused because you would have thought, are you applying the torque on the aluminum or are you applying the torque on the center one? I'm saying there is this cap. So when I'm putting the torque, both of them will take or resist or take the load of that torque. So this is the reason of putting that cap. So here I said the torque I am applying, both the steel and aluminum are taking chunks of it. So just so that you can start the problem, T node is equal to T aluminum plus T steel. Now, what exactly is the problem? The problem says that if the shear stress allowed in the steel is 120 megapascals and in aluminum it is 70 megapascals, then find the maximum T node that you can apply on this structure. Okay, so this will be your strategy for doing this problem. Number one, this is what you will do. You will say strategy is, okay, select, let's say, the tau steel. You can select tau aluminum, allowed, value first, and find the T steel and find the T steel. as well as T aluminium and T nod. Now use T aluminium, and find tau aluminium. Now, if your shear stress, of course, you have to come up with this strategy, but I'm telling you right now, is greater than 70 megapascals, then our answer of T naught, T aluminium, and T steel are wrong. Repeat the process. Repeat the process. Repeat the process. And now select. Shear stress aluminum allowable. And find T aluminium. T aluminium. Okay. T, yes, please. T steel and T naught.
We said that T0, T naught equals T aluminum plus T steel. Why we said it, Hujam? They have same torque,
No,
I guess.
no. I will tell you why did I say that. The torque that you're applying is being taken by both the aluminum, that thin layer of 8 millimeter thick, and this 50 millimeter fellow. Both of them are taking it. So both of them are resisting that applied torque. So it is not T nod is equal to T aluminium is equal to T steel. No.
Okay. So we are thinking like the vector thing. The T0 goes like this, the resisting T aluminum and T steel goes toward this, and T aluminum and T steel T steel plus T aluminum must equal to T naught. Right?
You can think like this,
Vector form.
or you can think it like the fact that just imagine that I'm putting a torque and both of them are right there. It's like somebody is putting some kind of a load and there are a couple of people who are trying to take that load. So exactly the same happening, that I am applying a torque and both of them are sitting there trying to resist it together. Okay, so
Can I have something wrong?
yeah, why not?
So how are we supposed to find the T, like torques, like T steel and TO and T aluminum, just by using only one shear stress of, let's say, steel? How are we supposed to find all three?
I will tell you, there is one more equation and I will talk about it. That will answer the question. But you have to give me 30 seconds because I want to complete this. T aluminium, T steel, T nod. Find T aluminium, T steel, T nod. If tau steel, here write different color. If star tau steel comes out to be less than, let me use purple color, comes out to be less than 120 megapascal, then our answer is correct. I'm not doing this question, you will do it. Now, his question is correct, by the way. Let me rephrase his question. His question is that you are asking us to find the T naught, and we have to, of course, find, how can we find it with one equation? The answer is, this is the answer to his question. What happened? Yeah, the answer to his question is, this is 1, and the second equation is T AL L over G J GJ is equal to T AL means aluminium. I'm sorry. This is aluminium. Okay, this problem is definitely going to be done by you. And the second one is T steel L over G steel J. This is aluminium, this is steel. This is the second equation. And anyone who wants to explain why did I write that? Why? Why did I write this equation? How did I write this equation? How did I say that the angle of twist? Because when you're putting a torque, of course, the angle of twist that the aluminium is subjected to, you will have the same angle of twist by aluminium, because both of them are you getting my point? There is a cap. There is a cap, and then I'm twisting. Both of them have to twist together, so there would be the same twisting. So that's why I came up with the second equation. One equation is T naught equal to T AL plus T steel. The second equation is phi of this fellow is equal to phi of this fellow. I think I wrote two G's, which is wrong. So I meant J. This is J. This is J. Okay, do it. Do it quickly. We have 15 minutes.
We have that name.
Huh?
This is not G, this is G.
One is G, one is J in the denominator.
One is G, this one is G.
So both of them are G. One is G of steel, one is G of aluminium.
That's the equation. This is two G, the parallel over G.
We will put the value of shear of steel around this here. Get hold of TS. Once you have TS, then you use the second formula, that is for aluminium. Hang on. Let me read the strategy with you. Select torque steel value, find the T steel as well as T aluminium and T naught. So you will use this shear stress value. You will find T steel. Once you have found the T steel, then you will substitute here. Hang on here. See the screen, this one. Once you are substituting here, you will get torque of aluminium. Are you getting my point? Huh?
Yes.
Got it. So now you have this, now you will get these two and find T naught as well. This is the first part. Now you will double check that the torque of steel that you have, I apologize, the torque of aluminium that you have got, you will
matches with the shear stress of the allowed aluminum.
good. You will see that whether it is exceeding the allowable aluminum or not, and this way you will proceed. Are you doing it? Do this problem, please. Right, shear stress is equal to
aluminum.
the formula is TR over IP, use TR over IP.
We should compare the much with this much, this would be again the same, would you allow this much given by shear?
No. Shear stress value use the formula shear stress is equal to shear stress is equal to PR over IP. Show me the formula. Now I'm writing it. It is radius over IP. IP in your textbook is J. Polar moment of inertia. Now what I am saying is substitute allow the value of P and taking the value of PS. Once you have PS, then you equate the two angle of this L over G equal to P aluminium, length of aluminium, G aluminium, G. Use this equation to find this. Then you have your aluminium. Now see what is the shear stress aluminium that you got by using this formula. If this value comes out to be less than allowed, that's good. Are you using shear stress is equal to good? Write down the formula. Shear stress of steel is equal to torque steel R radius over polar moment of inertia of steel. From here, tell me the value of torque of steel. Okay. Okay, so I think everyone is with me. Did you start the problem? Did you use shear stress is equal to TR over IP? Okay, he's with us. Good. So polar moment of inertia of aluminium is equal to pi by 2 into what is the aluminium? It is hollow, 76 and 8. So it is 60. Hang on. 76 over 2 is 38. 38 minus 8. Okay, thank you. 38 minus 8. So I have 38 power 4 minus 38 minus 8, 30. So you get divided by 1000 power 4. 1000 power. So you have J of aluminium comes out to be. Hang on. Now J of steel comes out to be pi by 2, 25 power 4 over 1000 power 4. So this comes out to be another value. Now shear stress steel is equal to, given the value of JS. Okay, same right. Okay, good. Okay, what was your question? Sure. Positive.
I get this ratio, that's what I call that equation. So after that, what we do, so we will say that he's still.
Did you find the value of T steel? Give me the value of torque of steel.
The lowest book will be 120.
So find the torque of steel, then using that torque of steel, substitute that, very good, and then find more torque aluminium using that TS.
After that, we will put in the aluminum part and this.
Double check whether it's exceeding the allowable.
Okay.
Okay. I think I will have to finish this quickly. So shear stress steel is equal to 120 into 10 power 6 pascals is equal to, anyone who got TS? Anyone? Okay, this is T. Good. What is the radius of this steel? How much? Okay, over polar moment of inertia. I don't know. So from here I will get TST equal to some value. Okay, and then how many students agree? We will see. Okay, then we will see. We have we will follow the second equation, which is this one, equation number 2, and I will say that T aluminium is equal to T steel TL over G J into, we will get G aluminium J aluminium over L aluminium, right? So from here
L will be gone because they're.
L will be gone. Then I have
And also plies will be gone because ply or two will be gone.
what will be gone? Oh, okay. Hang on. We have. So from here you can find T aluminium is equal to T of steel that you just found multiplied by G aluminium over G steel J steel. Give me the value. Now the value that you have got, you will say shear stress aluminium is equal to T. What is the radius, maximum radius of aluminium? It is 38 over J aluminium. Give me the value. T naught is equal to T aluminium plus T. Okay, give me the TST and TAL. Anyone to give? Anyone else? No one said we never.
There are calculators of finding different values. It's the same calculator.
Really? Anyone who got these answers? Yes.
Sir, can you confirm the value for torque of steel? The very first thing that we find.
No, I need a calculator and then I can. I think I also lost my calculator. Not the best, not the best day for me. Give me the calculator. Okay, what is T aluminium? Calculator is, okay. You mean torque of steel?
Yes, the first
So
thing that we
120
find.
into 10 power 6. Okay, then into JST, and JST is multiplied by pi divided by 2. Okay, into 25 power 4 divided by 1000 power 4. So you have this. Okay, now you will have divided by 25 into 1000. I'm getting 2945. 2945.6.
What's wrong with yours then? It's 2945. That's what.
Now, did you get 2945.6? Torque of steel? What did you get? 2945 for torque of steel.
I was wrong.
Okay, anyways, so then you will get anyone who got 2945.6 for torque of steel. Okay. Okay, anyways, then torque of aluminum. Okay, show me. Why you not doing wrong? Show me. Show me. Huh? What? PR over IP. What did you get? I don't know what. This is power. 4. We do it in front of me. What is this value?
I'm stressed, something like that.
See.
Okay, what is the radius? 150 × 6 into do in front of me.
1.40 something. No. Sir, is the radius for aluminum?
This is wrong. Huh?
What's the radius for the aluminum?
38. 38.
Okay.
For the aluminum is 38. Okay, anyways, from here you will get torque of aluminum. Double check it and hopefully it will come out to be. Check. Then R over IP, then you have shear stress multiplied by JS over rho is equal to RS. What is the value? 120 into 10 power 6 into pi by 2. What is the radius of steel? Its radius 25 by 1000. Okay. Power 4 divided by 25 over 1000. Okay. Is equal to TS. Okay. Let's do together. 120 into 10 power 6 bracket close into 5 divided by 2 into bracket close 5 divided by 1000 power 4 bracket close. Okay. What did you get? So divided by 25 into 1000. Okay, give me torque of aluminium.
I think
63 megawatts, 64.
Torque of aluminium
Yes.
in Newton meters. Give me the value.
no torque, not torque of the aluminum. Shear stress of the
So the final,
It's less than the.
yes,
Give me the torque of aluminium then, please.
it's 55, 13 Newton meter.
55,
13.
13
Yes,
Newton meter.
yes.
And what is the value of T naught?
Oh.
You have add them together.
So we check the shear stress on.
Good. You checked it. I'm happy.
So we can use those values to find.
Huh. So give me T naught. Add them. Anyone who can add 5513 with 2945.6? 2945.6 plus 5513.
8,458. Yes, we should be. So you remember the equation of T0 plus. Did you get the value? Did you get the value? No? Yes. Just come on, right? Give me the aluminium. Yeah, so calculate the shear for aluminium using the that's right. So we can use it in yes. So we can proceed with the values that we found. This and the total value is. So these are not correct. We should be able to compute. Because this doesn't exist, this doesn't exceed. Yeah, 64. If this is completely correct, this You didn't understand this, right? Let's first, okay, then you go ahead, you found this, and now you will double check. Find the. Okay.
टॉर्क ऑफ स्टील निकाल के फिर हमने साइज इक्वेट किए और उसके बाद टॉर्क ऑफ एल्युमिनियम निकाल के अब हमारे पास टॉर्क ऑफ एल्युमिनियम में टॉर्क ऑफ स्टील और हमने टी नॉट निकाला। आप बताइए
So, the question is done now, right? Because the question was that you had to find the maximum torque T naught that you can subject the structure to, right?
Okay.
And your concern was that either it would exceed the allowable value of aluminium,
Okay.
or it may exceed the allowable shear stress value of steel. The good part is, that we are making sure that the value of T naught that we have found does not exceed these limits, structural limits, the shear stress limits of aluminium. And
वो T तो torque नहीं है और ये T shear stress है.
which one?
ये T naught हमने find.
This T naught is torque, right?
Yes.
So what? So
So-
and these are allowable shear stress values.
Okay. So हम पहले T से shear stress निकालेंगे और फिर comparison करेंगे.
No, so no. We will use this shear stress values
To compare
find-
with the torque.
No, we will use this shear stress values 120 to find the torque of steel.
Okay.
Then from that torque of steel, I will find the torque of aluminium.
Yes.
Then I will use that torque of aluminium to double check whether I am exceeding the shear stress value of allowed value, that is 70. If I am not, then I will be happy that T steel value that I first found from using this, that is good. The T aluminium that I have got is also good because it is producing a shear stress that is within the allowable limit. Then I will add them together and that gives me T naught.
लेकिन मैंने बस एक चीज पूछनी है आपसे कि जो मैंने T of aluminum निकाला है, that is torque of aluminum.
Good. This is the torque of this is T. No, T of aluminium. Do you remember the value? So T of aluminium is
551.
5513.
सर इस T
You
से
can double check. I will correct it right now.
मैं कह रहा हूँ कि इस T से हम लोग shear stress निकालेंगे और फिर मैच करेंगे ना.
Which T are you talking about?
T of aluminum.
Using the
T
TS.
of aluminum. I
Right.
found out T of aluminum. TS से T aluminum.
Then using that T aluminum, you have to find shear stress of
That's the
aluminium.
thing I was asking.
Once you have got shear stress of
Then
aluminium, then you will
comparing.
come back. Then you will come back.
And then compare.
Then compare. And let's say,
If it's less than.
if it's less than, then that's good.
If it's greater than.
Then if it's greater than, that's the point. If it's greater than, then you will flip the strategy. Now you will start your problem by considering the shear stress of aluminium 70. Start from here, find the value of torque of aluminium, then find the torque of steel, then compare whether that is exceeding that. So are you following me?
Yes, I am.
That will be the second part of your strategy.
Okay, sir. Thank you.
Give me the calculator. Let's do it together.
Address of the JCT
So 77 and 27. Okay, let's do it. Let me pause the recording. Okay, and then we will do it. So
Man, what a long solution.
give me a calculator and the time.
My calculator.
Calculator? You don't have?
I'm trying to find it first. Where in the world did I put it?
There on the desk. No?
Okay. It's here.
Okay.
Oh. Here's the black pit.
Okay, so
Then we have
T aluminium. Okay, so let's cancel this. So we have T of steel, that is good, divided by G of steel
isn't that?
77 gigapascals. Good.
Have a nice day, hocam.
Yeah, you too, bye-bye. And this is 6.14 into 10 power minus 7. Seems correct. You multiply that, excuse me, with 27 into 10 power 9, which is this one,
Yes.
multiply by G of aluminium.
See here, something.
This is wrong. We will do 38 into 10 power 4. Then we have minus 30 power 4. Correct?
Yeah.
Oh, sorry, 38. I already,
It's hard
I
to
also did not.
write it on the calculator.
Minus 30 power 4. ठीक हो गया, divided by 1000 power 4 into pi by 2. Correct?
Yes.
2 into 10 power minus 6. Everything is correct. So where are we making a mistake?
And let me calculate this again.
Calculate.
We already eliminated the lengths of.
Yeah, that is fine. J of, no. Give me the calculator. Let me do it. I will do quickly. 3.142 divided by 2 into 25 power 4 divided by 1000 power 4. Correct? 6.1367 into 1. Everything is fine. I think you are making a mistake here. So let's do it together. 2947.2 divided by 77 divided by 10 power 9 divided by 6.14 divided by 10 power minus 7 into 27 into 10 power 9 into 2
Double cross.
into 10 power
6.
27 into 10 power 9 into 2 into 10 power minus 6 You're right.
And shall we let's have a look at the back page. Maybe we missed something. Or my answer is.
एक मिनट, नहीं.
Maybe.
Okay, so okay, J aluminium.
And you stopped the record.
Yep, I did not.